Okay, so we are at Groundswell Festival in the UK, and I am in the company of Dan Kittredge.
Yes, you
Hi,
are.
Dan.
How are you?
Great. How about yourself?
Doing well, doing well.
Yes, thanks a lot for taking the time and having this conversation with me. I usually record long format, almost 2 hours conversations, but here at the festival it's kind of complicated, so we are going to try and do a short 20, 30 minutes max conversation on the topic of nutrient density. It's a very deep and complex topic, which would definitely require a longer conversation to really get all of the information out, but we're going to do our best to make it work, right?
We should be able to cover some highlights in 20 minutes. Yeah.
Maybe we can start with you briefly introducing yourself and explaining the work that you've been doing in the field of nutrient density.
Yeah. Briefly introducing myself. Well, I grew up on an organic farm, so I come from the sort of the sustainable ag, alternative agriculture culture. My parents ran an organic farming organization for 30 years, so I was not just in the lifestyle, but in the movement. When I got married and had found no other better way to live a life than on the land, and a better way to raise children, I thought, than in nature and things, I set about being a farmer myself. And that's when I realized that I was not a very good farmer because I couldn't make a living, and I had pest pressure and disease pressure and failure to thrive and things like that. And so after looking deeply into the literature, reading books, going to conferences, attending seminars, practicing, was able to change a few things and be able to see my crops perform much more well and my economic viability dramatically increase, and started to think about how, even though I'd been in this world for 20 plus years at that point in time, there's a lot of stuff I didn't know. And so I started the Bionutrient Food Association in 2010 as an educational organization to focus on increasing quality in the food supply, which we mean as flavor, aroma, nutritive value, to focus on the results of the quality of the food. I had previously learned, I think it was probably 2006, 2007, about BRICS at the ACRES USA conference. And BRICS was the only real metric we've got still to get a number on the relative quality of a nutritional quality of food, which kind of blew my mind. And I said, what's the word for this variation in nutrient levels in food? And there wasn't really one. So kind of created this word nutrient density back then. And I kind of actually did. Talked to a bunch of the elders and said, what do we call this thing? And they didn't really have any good ideas. And so I said, well, how about this? And they said, okay, well, fine, we'll use that. So
nutrient density.
Yeah, there was no word for it back then.
Oh, so you came up with the term at the time. Yes.
Yeah. And then started the BFA in 2010 as an educational organization, working with farmers to help them understand basically how nature evolved things to work. Basically, plants have been growing for hundreds of millions of years without fertilizer and chemicals and tillage, and indigenous cultures have been doing a brilliant job for millennia working with nature without plows and beasts of burden and inputs. And so, I think only when you understand how the thing has evolved to work can you work in harmony with it. If you just learn what you've been taught, like you've been taught that you need to use fertilizer and you need to use tractors and you need to do the X, Y, and Z, just because that's what you've been taught doesn't make it true. And so the real thing is, how did nature evolve it to work? And once you understand that, then you can operate from a place of empowerment to be nuanced and things like that. So the first few years of the organization were educational, courses, conferences, local chapters, etc. As we saw that wherever we went and spoke, gave courses, it didn't matter geography, scale, climate, crop type. It was true that crops were behaving more well. They were performing, better yields, better flavor, better shelf life, better pest and disease resistance, lower cost of production. Got to thinking about how this could be a very powerful vector for systemic shift. If we could align the economic incentive with the ecological and human health incentive, we could properly disrupt agriculture. And so started research 2017 with our meter. We had three basic questions in 2017. One was, is there a significant nutrient variation in food? The second one was, if there is significant nutrient variation in food, does it connect to soil health or to things like soil type and variety and specific practice or certification label. And the third question was, is it possible to build a handheld, flash of light, non-invasive nutrient meter, consumer priced, that could be used at point of purchase to discern between this carrot, not carrot, or this apple, not apple, et cetera. So after, doing research for a few years, which we can go into the details of if you want, the short answer was yes, nutrient variation is quite dramatic, 2x, 5x, 10x, 20x, 40x, depending on what the element is or compound. It seems to connect primarily to soil health, soil life, and not to certification label or individual practice or variety or soil type. And we were able to build a handheld, consumer-priced, open-source flash of light nutrient meter as well. So that was 2021. And now, 2024, we're closing in on the definition of nutrient density in our first crop, beef. It sure looks like the ability to be able to bring meters forward that people can use in this, anywhere in the supply chain to differentiate quality, which can incentivize, more biological management practices and dramatically improve nutritional metric value is at our fingertips.
How do you define?
It's quite exciting. How do we?
Yeah.
Well, with beef, we engaged a global project where we had hundreds of farms, each sending in 3 steaks, so a steak from each of 3 different animals. We did about 200 different nutrients. So we looked at a bunch of different elements, some enzymes, some vitamins, fatty acids, amino acids, lipids, proteins, polyphenols, terpenoids, like a whole bunch of different nutrients in the steak. And then we took the manure from the animals and we looked at the microbiome, so hundreds of different species from multiple kingdoms in the manure. And then we looked at the forage, the fodder. Then we looked at the soil that fodder grew in. Then we looked at the management practices that were associated with those animals, and then also did some human health trials. So if you look at the biochemistry, the nutrients in the meat, you look at the microbiome. So basically where we're at right now is we're able to give the biochemistry data to the biochemists and say, of all these hundreds and hundreds of steaks, tell us which ones you think have the best human health compounds in them. And then we give the microbiologists microbiome data and say, of all these hundreds of microbes in the manure, look at these animals and tell us which ones you think are most healthy. And then we give the agronomists the fodder and the soil data. We say, look at these different, fodder regimens the animals were provided and the soil metrics, and tell us which ones you think were most optimal. And then we give the nutritionists the human health data and say, based on these, human responses to meat, tell us which were most positive and least positive. And so instead of presuming to know what nutrient density is, we create a big data set and provide the relevant components to specialists in those fields and find the patterns. So we expect, and this will be done by the end of the year, that the beef that the biochemists say is best will come from the animals that the microbiologists said were the healthiest, that will, when it's fed to humans, will have the best human health results. And if that's the case, then we'll have a few different biomarkers that we can use to calibrate next generation instruments with. So, we aren't presuming to know what it is. We're just trying to use the scientific method and, big complex data sets to find patterns.
Okay. So you said that you're hoping that this could disrupt the food industry.
Yes.
How so?
Expecting.
Yeah. What's your idea behind that?
Well, the idea basically is that if consumers have the ability to choose what's better off the shelf and leave what's worse, then there'll become an economic incentive for the supply chain to focus on nutrition as opposed to volume. In general, the understanding is that people care about themselves and their families, and whether they're buying beef or milk or rice or carrots or cucumbers, if they could know that this choice was 80 out of 100, this choice was 20 out of 100, we think they might begin to choose 80s and leave 20s.
So you see it as a score? The final sort of...
The final result, after all this metadata collection and, engaging the scientists and biomarker identification, then you engineer an instrument that when it flashes a light into the crop, what spits out on the screen to you is a score.
So that's something that everyone would have access to when they're going to the shop. and choose the products?
Well, I mean, it might start out as a $10,000 unit, but then rapidly become a $1,000 unit, and then a $400 unit. And the vision is that it'll end up being a camera in your smartphone. One of the cameras in your smartphone would be a spectrometer. Mm-hmm. And so we'll get Apple and Google and Samsung to be competing to put in to their phones high quality spectrometers that can be connected to our data. And so anybody would have access to it. But before then, it'll be separate instruments, but the results can be posted on social media or wherever.
Yeah. So as an expensive piece of equipment right now, could it already have a use for the distribution, for example, system, so that they could actually already measure, quantify the sort of nutrient density of the food that they buy from different suppliers and advertise that as being healthier?
That's the idea, is that, it doesn't get down to being in a smartphone before it's a $400, and that doesn't, not $400 before it's $1,000, not $1,000 before it's $10,000. So it starts out at the the B2B, the company level. Most consumers are not going to buy a $10,000 unit, but some companies will. And so they can get first mover advantage. They can begin to see the nature of the supply chain. And if they want to, they can make choices based on that. And then they can make claims based on that. Exactly. Yeah, exactly. So it's an iterative process. Yeah.
So you also mentioned that you did a lot of studies on different crops across a lot of different places, different soils, different farming systems and stuff.
Yeah.
What have those studies told you? What are the kind of key takeaways you've gotten in terms of the variation of nutrition in crops?
That the variation in nutrition in food is massive. So I generally say it's 2x to 10x in minerals. So, for example, with carrots, the carrot with the most sulfur had 4 times as much sulfur as the carrot with the least sulfur. That's 4x. The carrot with the most phosphorus had 8 times as much phosphorus as the carrot with the lowest level of phosphorus. That's, those would be between the 2x and 10x range. When it comes to polyphenols, antioxidants, those are the sort of the more complex flavor, health-giving compounds. It's more like 20x or 40x. So the carrot with the most antioxidants had, as many as the 40 carrots with the lowest level. The carrot with the most polyphenols had as much as 20 with the lowest level. So
it's massive.
It's a massive variation. And we found that across the board with more than 20 different crops that we assessed, roots, leaves, fruits, and grains. All of them had that scale of variation. So one thing is nutrient variation in food is massive. The second thing is that the only thing that correlated with, that was a causal factor, was soil life. So it doesn't matter whether you use this variety of carrot or that variety of carrot. It doesn't matter whether you use this soil type or that soil type. It doesn't matter whether you're certified organic or not. It doesn't matter whether you're cover cropping or not. The only thing that correlates with increased nutrient levels is increased soil life. So you can have this variety and bad soil life and get low nutrient levels. You can cover crop and have the soil be too tight and have low soil life. So you can be certified organic and have the soil be too dry and have low soil life. So for people that are attached to certain identities, I'm regenerative, I'm local, I'm organic, I'm no-till. None of those sort of identifying factors seem to correlate with quality.
So only soil life is
the level of soil life is what we found. Yeah.
What do we mean by soil life?
In the assessment we were doing previously, there was respiration. So a very rudimentary level of assessment. We basically take soil from underneath the crop and you dry it out, and then you add water to it, and you measure how much carbon dioxide comes out of it. That's called respiration. It's a respiration test. So by seeing how many microbes are down there breathing, that will correlate with the nutritional value of the food.
Okay.
Yeah.
Right. So do you see a future where instead of having labels like organic, regenerative, and so on, you would have also sort of a soil life score for a farm or a plot or a crop? Like that?
My future is everybody who's got a smartphone flashes a light and gets a reading. And
so it doesn't matter the logo, the stamp that you get anymore. It just, all that matters is the actual nutritional value of that food, and it will speak for itself.
That's the idea.
Yeah.
People don't really care about what the logo is. They care about how good it is. They think that certain logos connect to more nutritious, but they don't necessarily. And so if they have a more nuanced ability to discern, then the idea is that would be the thing that matters. Yeah. We'll see.
Yeah, yeah. How far away are we, in your opinion, to having these kind of devices available to the mass public?
It's not so much a question of time as a question of money.
Yeah.
So, should we have as much money as we need to do all the research? 2 or 3 years, we can figure it all out and start getting the meters out there. We've just spent 3 years raising the money to do the science on one crop, beef, because you have to do the science right before you can build the definition of nutrient density, before you can build a meter. So because we're a nonprofit educational organization, we're a charity, we're not a company, we don't have investors. Because we're committed to all the data being in the commons and not being proprietary or being, controlled with someone's IP, the logistical hurdle is raising the money to do the research. You can't build a meter to test quality until you define quality. You can't define quality until you've got the money to do the research. And investment money, investors want to control whatever you do. They want to own it. So it has to be donations. So the biggest issue is just the money to do the research. And that's maybe $20 million for all crops. So it's not much.
Yeah.
It's really not much. So our thought right now is we go forward with beef. We're just about done with that definition, and then proceed next to building the meters for beef and getting them out there. And if we can, succeed in proof of concept with one crop, if we can actually begin to shift the market with beef and people can see it and understand it, our thought is then that will help to inspire the future donation.
Yeah. Are there other organizations out there working on the same topics?
I would like there to be, because it would be helpful if we weren't doing it all by ourselves. But
but it's something that
in this way, in this comprehensive, systemic fashion, I'm not aware of anybody else on the planet doing it. No.
I'm fairly new to this whole space, but it seems to be a topic that is more and more talked about.
I would agree.
Popular.
We're beginning to feel that, like, yeah.
Why do you think that is? What is the turning point, the thing that gets people hooked that wasn't there before?
Well, I mean, good things take time. So, you gotta, first is an idea, then you gotta create a word, then you gotta start talking about it, then you gotta begin doing the research, then you gotta publish the research, and all the while you're talking to other people about it and they're thinking about it, and people are attached to their local thing or their organic thing or their regenerative thing, and and as you engage more deeply and you see, okay, this works well here but does not serve this purpose, and I feel like it's one of those things where nutrient density actually covers a lot of the bases that other things don't, and people who have been attached to other names or identities, have begun to see the limitations in them. And that, and the fact that the more we've been doing the research, the more we've been publishing the papers, the more we've been, getting the word out there. It just takes time for these ideas to percolate and ferment and people to hear about them and stuff like that. So, but I do think in the last 6 to 12 months, it feels like the level of interest and buzz and, receptivity and desire for nutrient density has become much more pronounced. So, just in time,
Yeah.
we didn't have this, we weren't as far along 3 years ago as we are now. So,
And that's the right time for you. You feel ready to talk about it more and to get the word out.
now that we actually have, basically a definition in one crop, we can show it. We can actually not talk about it, but show it, because some people can get the idea, but most people need to see something before they can get it. And so,
Has this research affected the way you eat and you buy food?
I think the biggest thing that's happened to me recently is understanding, because we've been doing a lot of work on beef and then understanding the broader correlations on meat. I grew up on a farm where we had our chickens on chicken tractors out in the fields. We had our pigs out in the woods. They were eating organic grain, and we knew our chicken and our pork were superior because they were out there in the woods, out there in the fields. And what I've come across an understanding about recently is that any animal that's eating like corn and soy is going to have an omega-6 omega-3 ratio, which is quite unhealthy. So I have stopped eating pork and chicken almost entirely, organic or otherwise, because until those animals can be fed sprouted fermented grain, they're going to be all basically not that good for you.
Sprouted fermented greens?
Grain.
Grain. Okay.
So if you take there's this thing called omega-6, it's omega-3. There are different types of fatty acids, and it's generally understood that you want to have a diet that is less than 2-to-1 omega-6 to omega-3. More than that, and you begin to have high levels of inflammation, which correlate with basically all chronic disease. So heart disease, diabetes, cancer, et cetera, have at their root this thing called inflammation. And excess omega-6 will cause inflammation in your body. So grass-fed beef from our study averages around 1.7-to-1 omega-6 to omega-3. That's pretty good. The American Heart Association says anything more than 4-to-1 is bad for you. Beef, sort of grain-fed beef averages about 8-to-1. I think it's like chicken averages about 15-to-1. Pork averages about 30-to-1. So the omega-6s are high in grain and they're low in green leafy plants. And so if you feed your chickens and pigs grain, then by definition, they're going to have high levels of omega-6, which is basically bad for you. If you take that grain and you sprout it and you give it a week, and it starts to have green shoots, and then you ferment it as though you're making sauerkraut or something like that, then you can dramatically decrease the cost of production. So the animals are eating fewer dollars of grain per pound of meat. Their omega-6 and omega-3 ratios get down to 1-to-1, and they're much more health beneficial. The animals have less disease, better microbiome. So
I didn't quite catch why it was less expensive, because you it's the same grain, so you have an extra process of having to sprout it and ferment it. So in my mind, it should be more expensive. Why is it not?
So if you take whole grain and you crack it and extrude it, so let's say if you're a farmer and you're selling a bushel of corn, you might sell it for $5. If you're a farmer and you're buying 50 pounds of grain, you might pay $20 for it. Now, why did it go from, in a bushel, maybe it's close to $50. A bushel sometimes is 50 or 60 pounds. So if you take the whole grain, it costs much less than the bagged, cracked product, right? So somebody's making money when they take the whole grain and they crack it and they, and they bag it and they sell it back to you. So you take the whole grain, and then there's a couple things. There's this things called phytase inhibitors. So grains are not, they're not evolved to be digested. They actually, from the perspective of the grain itself, the seed itself, it wants to go in one end, come out the other end in a nice fertility package and germinate. And so there's these enzyme inhibitors called phytase inhibitors, which make grain inherently indigestible. So traditional cultures would always soak their grain before they cooked it. In India, if you go to India, they'll put the rice in a bowl of water at night before cooking it the next day. They'll put their dal in a bowl of rice at night before cooking it the next day, because that's what they've always done. They don't necessarily know that that's what's happening, but functionally you release these phytase inhibitors when you begin the sprouting process. And so if you crack whole grain, not only does it begin to get rancid, but it also still has those phytase inhibitors, which makes it indigestible, which means that it's harder for the animal to digest, and so they have to eat more grain to get the same weight gain.
Okay.
And so if you take the whole grain and you crack it, which basically means that you're doubling or quadrupling the price to the farmer, which is increasing cost, and then the animal needs to eat more of it to get that same weight gain, then that's an increase in cost. You take the whole grain, which hasn't been cracked, so it costs less to begin with. You sprout it, it's much more bioavailable. They functionally grow faster on less cost.
Okay. Makes a lot of sense.
So it's more economically advantageous for the farmer. It's more nutritious for the consumer, and it's worse for the grain dealer.
Okay.
And it's worse for the veterinarian. And you don't need antibiotics. You don't have the animal disease. You don't have. So there's many costs that are, removed.
Yeah. Okay. So when you hear about these from the studies, sort of suggesting that eating meat or red meat or too much of it is bad for your health, isn't it just actually that's eating bad meat that is really with a really high ratio of omega-6 to omega-3, but if you eat the grass-fed, high-quality meat that has a good ratio of omega-6 to omega-3, that's actually much, much better for your health.
That seems to be the case.
Yeah.
Well, I mean, look at traditional cultures for millennia. I mean, meat was a significant part of the diet of many cultures for many, many thousands of years. And the levels of disease that we have now, they didn't have. So they were eating meat and they weren't getting sick.
Yeah.
So
And there were also
it's not the essence of meat. It's how it's produced.
how it's produced changes drastically, not just the environmental impact of that production,
Precisely.
but also the quality,
Nutritional impact.
quality. But
Which is not even talking about processing.
Yeah.
Because in many cases, you'll take a meat and they'll process it and make bologna or salami or whatever else, and it's got all these chemicals in it, which makes it even that much more worse.
yeah.
So-
and then the same goes for plant-based products, for vegetables and fruits and nuts, for examples, because obviously if you have sometimes 10 times more nutrients, micronutrients, phytochemicals and things like that in one carrot compared to the other one, means that you need to eat 10 of them, which is impossible, first of all, that and would also bring like more sugar, more other problems like that. So how, even eating a healthy diet of vegetables and fruits today, how are you supposed to get as many nutrients as you would have when everything was growing in healthy soils a few centuries ago?
Many people talk about how there's not a lot of flavor in their carrots or their tomatoes. And that is exactly our inbuilt nutrient monitoring systems called our noses and tongues telling us that they're not good. I mean, people talk about their children don't eat fruits and vegetables. And I say it's because they're animals and they know better. They have an animal instinct called their nose and their tongue. And when they bite into a carrot and it doesn't taste good, they don't want to eat another bite of it. Whereas if you give a child a tasty carrot, they'll fight over it. So, I mean, nature has this whole thing figured out. We just think all carrots are uniform, and they're not. All beef is not uniform, all carrots not uniform. And so if we can establish a empirical instrument that can be used to discern the difference and help people choose the better, our thought is that market pressure of people beginning to choose the better stuff off the shelf and leave the worse will incentivize the producers to focus on nutrition as opposed to volume. Because right now, the farmer's paid on volume, they're not paid on nutrition. So we need to shift the incentive. And that's the strategy.
Yeah, I see. We've been talking about phytochemicals quite a bit in this conversation, and I realized that I didn't stop to just to ask what is phytochemicals, because it is a topic that is it's a term that I see used more and more, and that I've only really learned about recently. But I realize I'm hoping a lot of newcomers to this space are listening to the podcast and trying to learn the basics. So I want to make sure that everyone's on board. What is?
Yeah, what are phytochemicals? So there's lots of fancy words for them, like antioxidants and terpenoids and phenolics and polyphenols. So there's, in science, we've got fancy words for them, but effectively it's flavor and aroma. So if you've ever eaten a tomato fresh out of the garden and experienced that like delicious, flavor versus a tomato off the grocery store shelf, or a carrot from the garden versus a carrot or maybe a peach. If you've eaten a peach that was ripe off a tree, you're like, oh my God, that's amazing. Versus a peach that was, picked raw. That variation in flavor is functionally a variation in phytochemicals. Those things which science calls phytochemicals, our tongue calls flavor. Okay. And they're basically complex compounds that correlate with health-giving attributes.
Okay, so
they're health-giving nutrients.
Yeah, so not just taste. They give taste and also have health.
Taste and flavor are health-giving because we have evolved for millennia with very sophisticated nutrient monitoring systems called noses and tongues. So what we call flavor is nutrition. What we call bland is lack of nutrition.
But the food industry has learned to trick us a little bit with that, with very unhealthy...
build synthetic compounds and stuff it into otherwise bland food and trick our tongues.
It's amazing, but it's terrible for you.
If you take a conventionally grown corn plant, which is volume but not much nutrition, and add some flavoring agents, your tongue might think something's good there, but from a biochemical standpoint, it's relatively empty of the things your body wants.
So when using your intuition to know if a food is healthy or not, you need to also take into account whether it's been processed or not. If it's a fresh, whole food.
If it's a processed product, I mean, sometimes they call that junk food. Do you guys say that in Belgium? You guys call it the word junk food?
Yeah.
So I would say if it's junk, it's junk. And if it's food, it's food. But if the word is junk food, we actually understand that it's junk. So stop calling it food, just call it junk. If it's a processed product, inherently, it's not really food. I mean, you can eat it and your body will be built out of it, but your body will be built less well. You will begin to degenerate the more you eat that stuff. Your body will begin to break down because it doesn't have the sustenance in that your body needs to function well.
And again, now having a tool in our hands where we can actually see what's inside of those products. If you could really see it, not just look at the package and just see a bunch of numbers and figures that don't really mean anything to us, and understand what we're eating. Maybe it could be a big shift psychologically for people to be like, what? I'm eating this crap here. And I have just this next to it, which is delicious, fresh, whole foods that are 20 times more nutritious. And that could create a big shift in the way people make decisions in the supermarket.
That's the idea.
Yeah. Well, I really hope to see that happening as fast as possible, because I do have also the feeling listening to you, and obviously I've listened to other podcasts where you're a guest, and I'm trying to keep up with the topic. And I also believe that this could really change a lot of things in the food industry, and the food industry needs a change, massive change. For obvious reasons, health, and ecosystems. Farmers' well-being.
We're going to die otherwise.
Exactly. So I'm really, really curious to see what is going to come out of your research in the coming months and years. And thank you so much for the work you're doing.
You're welcome.
Thank you so much for taking the time to have this conversation with me. And cheers.
Cheers. I would say anybody who also wants it to see it happen, we're a charity, we're a nonprofit, so you can go to our website and donate $5 a month and be part of the solution.
Absolutely.
I mean, it's not going to happen until we have the money to do the research. That's the thing. It's like you can have great ideas, but until they get accomplished, they're just a great idea. We are not sitting on piles of cash, and it does take money to do the research to get over the hurdle. We welcome support.
Of course. Please donate.
Bionutrient.org is the website.
Yes. And so just as a reminder, it's the Bionutrient Food Association is the organization you created.
Right.
Brilliant.
Sweet.
Thank
you very much.
Bye.
Okay.